Hi, this is Miss Claywell here. We're going to start 2.6, derivative of trig functions. So far we only know sine and cosine. So today we're going to explore tangent, cosecant, secant, cotangent. So the derivative of sine we know is cosine. Derivative of secant, or derivative of cosine is negative sine. So we're going to take that and think about how to find tangent. So I can write tangent in a way that allows me to use the quotient rule, sine over cosine. We know that's low, d high, minus high, d low, and then we square what's down below. If we think about how to simplify this, this becomes cosine squared of x minus sine squared of x over cosine squared of x. I made a mistake here. Sorry. High d low would look like that. And then this ends up becoming, we know that sine squared plus cosine squared equals a 1. So that's our Pythagorean identity that allows us sine squared plus cosine squared to become a 1. And then I know out of reciprocals, this is the same as secant squared x. So sine is secant squared x. If we continue doing this for the rest of these, we'd end up getting cosecant is negative secant, or cosecant x, cotangent x. The derivative of secant is secant x, tangent x. The derivative of cotangent is negative secant squared x. Notice how these two seem to be pairs with everything being opposite. And then my tan and my cotangent are pairs. So you now know all your trig identities, or all your trig derivatives. So moving on to the next part. Here it wants a equation of a tangent line. We can write this instead of y1, f of a, m is f prime of a, or the derivative at a. That's going to be our slope, or x minus a. So let's take this into consideration. Let's find our point. I know it's going to be 5 over 4 comma something. So let's find f of 5 over 4. Tangent of pi over 4 equals 1. So there's my point. My slope is going to be the derivative value at pi over 4. So first let's find the derivative value. Or let's just find the general derivative. This is going to equal secant squared of x. And then I want that at pi over 4. So my slope here is 2. So my equation is y minus y1 equals slope x minus pi over 4. So this is similar to what we have been doing. I just used my trig derivatives to find the slope this time. Okay, flipping to the back of your notes, example 2a. This one's the derivative of the following functions. So I'm just going to take it. I see there's addition here, so I'm just going to focus on this first part. I can keep my constant of 3 in the front, the derivative of cotangent. I'm just going to my trig derivatives that I found on the front page. And that's all I need to do here. If I look at my second part, I see I have the product rule occurring. I'm multiplying two different functions, so then I need to use the product rule when I find the derivative. Derivative of the first, regular second, plus regular first, derivative of the second. Then from here, I can just simplify and see if there's any like terms that end up canceling out. So that is all I'd be able to do for this one. I can't simplify it any further. So this is similar to what we've been doing. We're just now applying our trig derivatives. If you feel comfortable trying this on your own, go ahead and pause the screen and try it. This example B, I see that I can take the product or the quotient rule of low d high minus high d low, then we square it down below. So my derivative of g, if you want to think of it this way, is also my derivative of g with respect to x, low d high, the derivative of 4 is 0, minus high d low, then we square what's down below. So we can work to simplify this. I see everything has a secant. If you need to show less steps for this, that's fine. I see this simplifies, but I can divide a secant from the numerator and the denominator. I'm going to try to highlight this here, and you guys can see that this becomes, I can apply a trig identity there, and that can become just a 1. Or, and I made a mistake here that this should just be, once I divide out the secant, I only have a secant there. So if you want to make a note from how we got that, that's a Pythagorean. I feel the need. We got that 1 from the Pythagorean identity. And then I can write this 1 over secant minus 4 tangent over secant, which we can see this as cosine. And then this would simplify to sine x. If I'm going to show a little bit of work over here. So sine, or tangent is sine over cosine divided by secant. That's the same as 1 over cosine. And remember, if I multiply by the reciprocal, or dividing is the same as multiplying by the reciprocal. So this just gives me a sine x. So this is my final answer. There's a more efficient way to do this though. If you wanted to, you could just see this each as we could break this up. We just talked about how tan over secant just becomes sine. And then this becomes 4 cosine x. So to find the derivative would really just be cosine x minus 4 sine of x. So a lot of these are taking what we used to do and just applying these new rules. So I see here that I have 2 functions going on, my x to the third and cotangent x. So when I take the derivative of this, I'm going to need to use the product rule. Derivative of the first, regular second, plus regular first, derivative of the second. And then I can try to just rewrite this. Sorry, that does not look good. And this here is my answer.
Oh my god, they've been here the whole time.
Miss Woodard says hello, you guys. She found her keys. So there wasn't really a more efficient way to do that one. That one is what it is. This one, I can rewrite this one
Look at those little guys.
as 7/5 times 1 over secant x.
Come over my. Where did the ice cream go?
Okay, so example D can also be simplified. We can break this into 7/5 times 1 over secant, which we know is 1 over secant is the same as cosine x. So we should be pretty familiar with taking the derivatives of these by now. Derivative of cosecant is negative sine x. So it is always smart to, especially with the trig ones, to see if we can rewrite it in a simpler form before we start taking the derivative. If you would have done low d high minus high d low, then we square what's down below, you would still end up with the same answer, but just spend a lot more energy.